This is the second part of our big data part of week 3 materials. So this diagram shows data analytic pipeline. From the beginning, we have devices which could collect and record sensor data, for example, which have us collect the data generated. And then first step, we are going to do cleaning. You know, in reality, in most cases, you will find missing data, a lot of them. And also, we want to extract important information and do some annotation. For example, I'm currently working with NERC funded project. In that project, we are monitoring landslide. So we installed 200 sensors on a slope of hill, which we collect the data, and then we realize a lot of data are missing data, and then we annotate some event, for example, landslide, over flooding in that region. Therefore, other researchers can do some analysis based on annotation. So because landslide is a specific event, they want pay special attention to. And then most cases we move on aggregation. For example, we summarize the rainfall in certain time period. And also we want to do some averaging, 7-day averaging, weekly or monthly, and to identify the rain season or dry season, for example. And then next step, we try to build models and analyze what's happening. We have rainfall, wind speed, temperature, etc., several features. So we try to build a model. In this case, would be on what kind of rainfall situation, in what kind of wind speed situation, and in what season, for example, they are more likely have a landslide than rest of the year. And the interpretation, so we have a team member who's in School of Geography. They could have a look at our result and say, given this, we discover some interesting pattern given the data. So until then, we will realize the data makes sense, become useful and meaningful. So in several study I have been doing, my personal experience agree with the study, which shows that actually data scientists will spend a lot of time to do data processing, data cleaning, etc. before actually we run machine learning models. But for you, in most cases, you are going to use benchmark dataset for your assignment or your study, and then you probably realize the data has been already processed because they are benchmark and a lot of people have to use. However, if you do some real-world data analysis, you will realize data cleaning and then pre-processing and even domain knowledge from expert on how to process data will take a lot of your time and effort. So big data, there's a lot of problem with storage. Recently, probably you already know the news about some data which had missed because they use Excel to store data about COVID-19 cases, which has been identified NHS. Then I think they probably now use a different approach. So you are a data scientist, you probably can have addressed this problem. I think NHS data about COVID test or test result given the current number probably are not in a big data scale. However, you can see they still have a problem with the tool they have been chosen, Excel, and also depend on different version of that. So in order to deal real big data, we probably need a better tool for that. So new infrastructure, here we are going to learn cloud, for example, Hadoop, MapReduce. So MapReduce is one approach, okay? And then storage solutions, bigtable, NoSQL. So I know some of you have already studied SQL in other in previous study, and then we are using different storage solution for big data platform. And also, as we have seen that because big data, we probably need to use other data mining or algorithms which have to process, explore data in big data environment. I know you'll probably study other data science related modules, which probably we only deal with small scale data, which you can use SQL, you can use MATLAB, you can also use simple Python packages to process them. But for the big data, given the scale and the volume of data and the three V's, probably we use different approach. So first one is about a scaling of the data management. So if we look at the history, over the many years, different people use a different way to store data and make queries, and then extract information from the data, and SQL is quite fundamental. And then a relational database management system has become very stable for several decades, and I think in major industrial organizations they are still using a relational database management system. This has been in the market for many years. However, in the later years, the distributed database has been introduced to address the large-scale distributed problem. We may have discussed a different way to, in terms of partition of data source to in different way on the SQL server later on. Recently, we have seen other ways to deal with data. Oracle, IBM, Microsoft are the major relational database vendors. They provide the majority of the product in the market. So we already know that the cloud is infrastructure which will help us deal with big data. Even our Outlook, which is on the cloud. So a lot of things are on the cloud nowadays. Some of them probably we are not aware of it, even we are using it. Previously, there are different ways use cloud computing. For example, SaaS is a software service. So you just access the internet and use the application, and without understand how the application has been stored and executed and analyze your data, for example. And then the utility computing is a way of pay-as-you-go computing. So you use resources as you need without any upfront cost. And then you get the bills based on how much you have used. And you can imagine when you use it, you are not aware how many resources you are using, but you can imagine you have unlimited resources for you to use, and the end of the day you just pay what you have used. So Jeremy and I and another student had a study, especially consider cloud computing deployment, and especially on the cost modeling situation. So actually, we got some data from a local big IT management center. We got their usage data. We realized if they can use cloud computing, they can save their cost significantly. So if you're interested in this, you probably can have a look at the paper, which is published by a good journal called Wireless Network. So why now? Cloud computing actually is everywhere. It is the major things now. So because we have because they're very large data sets there, and then you don't have to use lot of local computational resources, and also the broadband internet is quite good, so the speed is good enough, and also a lot of software packages and data application already there, so we don't need any local installation. We probably just only access them. And also it's about the economic things, which make much cost-friendly to the end user. So this is a diagram of a warehouse of large-scale computing, and it is a data center in Oregon. And because there are a lot of mini server and machines, they generate a lot of heat. So nowadays they could trying to reuse the energy which generate to do some heating or energy conversion. So I know some data center even put the server into a very cold river in order to cool it down. So this is economies of the cloud user. This diagram shows very simple situation on the left and right. On the left is the one we have just mentioned, that a local IT center, which they bought a lot of servers, and then they have fixed capacity all the time, 24 hours per day. And actually their demand are not equivalent to the capacity all the time. So you can see the demand sometimes they are a lot of idle, people don't need them, and most of the time you can see the resources has been wasted. But if this IT company, local company, they can choose online one, they probably only order a slightly more than they actually demand, which will save a lot of cost. So this case is underutilization, waste a lot of resources. On the other hand, this diagram on your right, you can see sometimes you have, if you lower your capacity on your right, you can see that sometimes your demand are not met. So this one cannot match your demand, although you lower the cost, but sometimes you cannot meet the demand. Therefore, you probably lose some revenue because you cannot run the business, or some user left you because they cannot provide sufficient services, so they can become lower demand. So that's why the motivation of a cloud user. So if you cloud user, you're using shared capacity with millions of people. So in average, because it's global operation, so in the end of the day, it's likely the capacity will level. So they will be less dependent on one organization's time variant demand, or they will become even better management for one particular organization. So they have a lot of organizations. So these are related previous time in terms of design of cloud computing, distributed computing. So there are a lot of machines in different places that connected. Distributed database, also they have database everywhere. They also have the copy. And grid computing was very popular, I think, in the late 90s. Even UK has a grid computer center, but nowadays nobody mentioned that. So the big giant organization have provide cloud computing service we are using, and also for the national scale, the infrastructure globally. Okay, we got data, we got the cloud to put our data on. So what shall we do with that? So there are several scenarios. Given the data, what do we actually want to find? Okay. So this is about data mining. So we want who are the customers we're buying, most likely, for example, to complete the job, to do the competition. So revenue margin. So based on the data, actually, end of the day, we want to answer this question. You may find this is similar to SQL. So giving you SQL, you can make a query, say, my employee number, give me a list of employee number who has in certain payment scale and in IT department and who joined us 10 years ago. All this information can make we need to discover this information from query from different ways. But you can see that SQL, you must make it very specific on what you want to ask, and then SQL query can generate the data for you. So decision support, okay, based on what we have found here, we understand this information. What we can do is the next step, which is called decision support. Decision support is something you make based on the information we generate, and then you make what you're going to do. So, some new term called business intelligence. So, use the information we have discovered to manage and control business. Okay, manager and understand the business demand, make a judgment, and finally is a working plan what we are going to do. Traditional approach, we put in spreadsheet, manually process, and nowadays it's a bit outdated. Okay, so for example, they have a data warehouse, and they could store data, and then probably they make queries, like what we said, and generate some information. And at the end of the day, based on this information, we do some process. And then make a decision if we want to do a strategic plan, if we want to sell more of these products, or we want to sell different things. Nowadays, data analysis goes on web, in the web content, so we can capture user interaction level. So, for example, if you have done the module called web development, so PHP server can capture the information you typed in, and you want to process, and then you collectively there are a lot of customers, so you can make a suggestion. We store these products more, and these things are all online. So. Therefore, we need to do data analytically in the web content. So in the cloud, why we need to do data analytics in the cloud rather than offline? For example, it's also about capability of analysis. For example, I have one computer. If we want to process just a search, for example, scan 1 terabyte data, I need 23 days. And if I have 100 nodes, we can order from Amazon. We can process the same data within half an hour. So this makes a huge difference that how are we going to process our data, not just in individual machine, but we use cloud. So divide and concept is divide and conquer is a concept in data in computing, which have us to solve problem, divide to small part and solve them, and then collect all the solution together. For example, data partition. So we have huge data, we cannot process all of them in one go, so we process in different parts and then process them. So they bring us more about cost efficiency. Okay, so historically we know a parallel database management system. So MapReduce is what we are going to learn today. And traditionally, the database management system they has been used for many years. So next slide we are going to see this. For example, historically they have a certain research project. They realize the problem of big data, so they try to process data in parallel. Okay, this is a very nice diagram regarding to a parallel database. So there are different design in parallel database. So for this one, you got several many CPUs in one server, and then you have one operation system, and all these database partition. So partition 1, 2, 3, 4 are sets install sets in the process in the same server, or you could use different CPU machine. You can imagine there are different machines to process. So this partition, you process one machine, next partition, you process another machine. So DBA is database administrator. They do partition, to do optimization, etc. So this will give us cost efficient in terms of process data. So in terms of partition, there are many ways to do a partition. So they have a horizontal partition. So for example, if you have learned database, you know that relational database are in the table. So you can divide table into multiple tables, contain some or number of columns. So when I say column, I mean attribute or features in database term, but a few rows. So each row is one record. So partition can be done by horizontal one. For example, you can divide the whole database to first year, second year, because each record represents, for example, one student record. So you can partition them by the rows. But sometimes also you can partition data use horizontal way, vertical way, which means you got like 10 or 100 attributes, but you don't need deal with all of these attributes in the same time. So you can, for example, student have certain attributes, 100 attributes. For example, you can divide your student ID, and then possible you can have one table is particularly for their exam, one table is particularly for the modules. So you can divide them, basically more information, the third table. So you can use some primary key which you can divide the table. And for some cases, you only need to access one table rather than several tables at the same time. So you reduce the number of attributes in that table rather than you reduce the rows of that table. So that is a parallel database. So the next part we are going to map reduce.